Hello and welcome to Martin Maths. We're continuing and finishing the last of this higher paper series, higher paper 2, question 25. It's a question on probability. Now we're told that there's some red and some white counters in a bag, and at the start there are only 7 of the counters that are red and the rest are white. So the rest we're going to call X. Now Alfie takes at random a counter from the bag. He does not put the counter back in the bag. He takes another random counter from the bag. Now we're going to find the solution to this. The probability that the first counter that Alfie takes is white and the second is red is 20/180. So they've given us the final probability, but we don't know how many there are. So we're going to work out the number of white counters in the bag at the start. So I'd like to set this up as a tree diagram. This is the first time that he takes a counter, and then he takes another counter. And it could be red or white. Now we know that there are 7, but we don't know how many there are. So I'm going to call 7 out of X, and then this must be X minus 7 over that X. Now the next time that he takes a counter, this would reduce to 6, and this would be X minus 1, and this, the white, well, it wouldn't have changed the numerator, it'd still be X minus 7 over X minus 1. Now they've told us here the probability that the first counter Alfie takes is white and the second is red would be going down white and then red. So we need to work out this one here. He hasn't taken a red one, so there's still 7 and it's out of X minus 1. So this is the only route we need to worry about. The first counter is white and the second is red. So they're saying the probability of white and red is 21/80. So that's an AND rule. We get that from multiplying X minus 7 over X times 7 over X minus 1. So now we've got an equation that we can solve. 21/80 equals X minus 7 over X, that's the white ones, and that's the red ones. So what I'm going to do now is multiply the numerators together. I get 7x minus 49 over x squared minus x. I can then see that the numerators are all multiples of 7, so I'm going to divide through by 7. I'm going to get 3/80 equals x minus 7 over x squared minus x. And then I'm going to cross multiply. 3x squared minus 3x equals 80x minus 7 times 80. Well, 7 times 8 is 56. So it's 560. It is a calculator paper, so I could have used a calculator then. Now let's set up a quadratic. 3x squared. Minusing that 80 minus 83x, and then plus 560. It is a calculator paper, so I'm going to use the quadratic formula here, where a is 3, b is minus 83, and c is 560. Now remember the quadratic formula is, I'll just draw a line there, is x equal to minus b plus minus the square root b squared minus 4ac all over 2a. And if we substitute those all in, we've got 83 plus or minus the square root of minus 83 squared minus 4 times 3 times 560. And we hope that, well, that should be a positive number. Otherwise, there wouldn't be a solution, all over 2 times a. Now, for space on the page here, but also because it's a calculator paper and we can use our calculator, I could set it all up. I go 83 plus the square root, just using brackets here, 83 squared because I don't need to worry about the sign there, minus 4 times 3 times 560. And then I go to the denominator, divide by 6, and I get an answer of 16. Could have taken certain steps to do that. But there are two answers to that. That's the positive. And if negative gives me 35 over 3, which is 11.6 recurring, now we know that this had to be a whole number because x is the total number at the start. So I'm only take that x is 16. Now if x is 16, that means x minus 7 has to be 9. So the final answer is 9. Okay, so thanks for watching. It's quite a lengthy question there. It was for 5 marks. We had to use tree diagram and the AND rule. We had to use some algebra, and then we had to use the quadratic formula. Thanks for watching. Don't forget to like, subscribe, and share.